A warm welcome to all the students. In this lecture, we are going to learn packages in Java. Okay. Although we have used something called as package, even when writing a simple hello world program, this is a chapter where we are going to explore what are packages. Okay. So, packages can be considered as containers for grouping different classes and interfaces together. In fact, packages are, they are Java's way of grouping a variety of classes and interfaces together. The grouping is usually done according to the functionality. For example, there is an inbuilt package called as AWT, Abstract Windows Toolkit, which contains all the classes which are required for coming up with a graphical user interface in Java. For example, you will have a class called as window, you will have a class called as menu, you will have a class called as color, and so on. So all these classes, they are related. So all the classes which are related, okay, which can be used to come up with something like graphical user interface, they have bundled all these classes into a package, and they have given the name to the package as AWT, that is Abstract Window Toolkit. So by organizing our classes into packages, basically there are certain benefits that we get. Let us see what are the benefits. The class contained in packages of other programs can be accessed. So suppose now we have a class which is there in another program's package. Okay, so our program can access that particular class if required. Fine. Then in packages, the classes can be unique compared with classes in other packages. For example, suppose we have a one package called as package 1, and there is another package called as package 2. Now, although in Java the class name should be unique, it is possible that package 1 can also have a class called as class A and class B. Package 2 also can have a class called as class A, class B. Notice that although this class A, the name of the classes are same in both the packages, okay, they are distinct because these are the classes within this particular package and these are the classes within this particular package. So ultimately, package can be viewed as a directory. Okay, in Windows we have folders or directories, right? So package basically is nothing but a directory. So you can say that class A, class B, these are the classes present in this particular folder, and these are the classes present in this particular folder. Now, if you want to access say class A of package 1, then we can just write package 1 dot class A. So the classes within the packages are accessed using dot operator. So you write the package name dot the class that you want to access. Suppose you wanted to access all the classes within package called as package 1, then you can say import package 1 dot star. Okay. So the advantage of using packages in Java is that the classes can be unique compared with the classes in other packages. So you can have class A and class B as unique classes, okay, and class A and class B in package 2 as unique classes because they are now in different domains, in different packages. Third, packages provides a way to hide classes, okay, thus preventing the other programs or packages from accessing classes that are meant to be for internal use only. So whenever we have packages, all the classes which are stored in the packages, okay, if they are not declared as public class, then outside the packages those classes cannot be accessed, right? So if you want to hide a particular class from being accessed from outside program, you can just declare that class as non-public class in the package, right? So in the package, whichever classes that are declared as public, only those classes will be accessible to programs outside this package. And if you want to hide a particular class from the outside world, you want to use it only for the internal purpose, then that particular class within a package, you can just declare it as non-public. Don't declare it as a public class, right? We are going to see this later. This is a way how you can hide classes. Then the fourth advantage is that, okay, packages gives us a way of separating design from coding. As we shall see, creating packages, it involves properly giving a structure to your program, because we are creating folders, then within one folder another folder. So grouping the classes together in this kind of hierarchical fashion, okay, ultimately is basically designing. So this is a way of separating the design from coding, right? Now packages in Java are of two types. You have Java application program interface packages and you have user defined packages. Now Java API packages are the ones which are inbuilt in Java. These are given to us as a programmer, we can use them, okay, and we have already used a few of these particular classes, right? Few of these particular packages. So let us see what are Java API packages in more detail. Okay, so there is a package called as Java, okay, and under this Java package you have package called as lang. Okay, so this particular package can be accessed by writing java.lang, package within a package, right? So within package called as Java there is a package called as lang. So how do you access? You just say package name, the outer package name dot the inner package name. So it is java.lang. Now what is this lang package? This language, this lang package basically supports all the classes pertaining to the language support, right? Now these classes are basically used by compiler itself. Therefore, whenever you want to use a package, any class from java.lang package, you don't have to write an import statement saying that import java.lang.star. We never write this, because by default compiler uses this particular packages, the classes within the package within this particular package are used by compiler, so they are automatically imported. You don't have to write a separate import statement for java.lang package. Now what are the contents of this java.lang package? What are the different classes? There are many. Few of them are these. So basically there are classes for primitive data types, there are classes for strings, okay, string buffers, there are classes for math functions. So you have heard about java.lang.math, okay, for math function there is a class. Then there are classes for thread, so you are going to learn something called as multi-threading after some time, okay. So all the classes for threading and also the classes for exception handling, all these are present in java.lang, okay, package. Then you have another called as Util Package. We have already used a scanner class in this Util Package. So what is java.util package? It basically contains utility classes, okay, such as vectors, hash tables, random numbers, dates and so on, and it also has something like scanner class that we use for taking input from the keyboard and many others, right? So this is java.util. So it contains all the utility classes. Then we have java.io. This is another Java API package. Java.io basically it contains all the support classes required for input output functionality, okay. So this contains facilities for input and output of the data. Then you have java.awt. I just told you right now before some time that what is AWT? It is Abstract Windows Toolkit, right? So basically this package contains classes for graphical user interface. If you want to come up with a graphical user interface, okay, it contains all the classes that can help you to achieve that. So it includes classes for windows, buttons, list, menus, color and so on. All this is present in the package called as java.awt. Then there is also another API package called as java.net. As the name suggests, it contains classes for networking. All the different classes that you are going to use for networking are present in java.net. Then there is a class called as java.applet. That's the last API class, java.applet. So we already know that there are something called as applets, right? You have Java application and then you have something called as applets. Applets are run on the browser. So if you want to create or implement applets, java.applet package has all the classes for it. So these are basically the Java API classes that we have. Now packages in Java are also, it allows you to create something called as user defined packages. We have already seen Java API packages. These are predefined for you and you can also come up with your own user defined packages. So now let us see how we can create, how we can access this user defined packages. Now, so before even going for creation of such packages, let us see how we can use system packages. For example, if I want to use say a class called as color, which is present in AWT java.awt package, then I will have to write the import statement as import java.awt.color, where color is the class which is present in java.awt package, right? Now many a times you are not sure which classes are you going to use, because in a package you may have multiple different classes. So when you are not sure which class you are going to use, then you write a general syntax saying that import java.awt.star. So dot star tells the compiler that you are going to import all the possible classes which are there in that particular package, right? Now in general, if you want to use any system package, the syntax is you write import statement, then write the package name dot the class name, if you know which class you want to import. But if you don't know which class you want to import, then you can write a general statement saying that import package name dot star. So star means import all the classes which are present in that particular package. So when I say import java.awt.color, notice that there is a folder called as or there is a directory called as java, which is nothing but package. So this is a package containing AWT package. So there is a directory called as java. Now within this directory there is another directory called as AWT. So outer package called as java, and this outer package, it contains AWT package or directory. Now within AWT package or directory you have classes, different classes which are part and parcel of that AWT package, like color, graphics, image and so on. So if you want to access the color class, you will have to write import java.awt.color. So by saying that, we are just saying that you access directory called as java, within that access directory called as AWT, and within that you access a class called as color. Okay. Now what are the naming conventions while creating the packages? So package name basically begins with lowercase letters only. Example, just see, I have written here double y equal to java.lang.math.square root of x. So I am basically calculating square root, okay, and square root is a method, inbuilt method, which is present in a class called as math, inbuilt class called as math, and this math class is located in java.lang package. So lang is the package name, math is the class name, and square root is the method name. Okay, so that's why the package names are always written with the smaller case letters, so that you can distinguish them from the class names that begin with capital alphabet. Another example, if I just write java.awt.points pts, what I am trying to do is, in java.awt package there is a class called as points, which represent any point on your xy coordinate system, right? So I am accessing the points class, and I am creating array of objects of type points. So PTS basically is nothing but it's an array of object of type points. So object is of type point class, and this point class comes from java.awt, right? Next we shall see how can we create user defined packages, then we will see how to access such user defined packages, and then we will see how we can then use these packages and do various things. Let us now see how to create a user defined package in Java. Suppose I have a folder, so you create a folder, okay, you just name it as my project. This folder or directory called as my project will house your source code, say source.java, and it will have another subdirectory or subfolder which will house your package. The name of the package will be, say, my package. Okay. So as we have already seen, package is basically a container. So when you consider package with respect to a Windows operating system, package can be considered as a directory or subdirectory. So this is the my package, and now within this my package I want to create a class. Let's say my class. .java. Okay. Now once the package once the class called as my class is created in my package, next I will have to execute this particular class. Okay, I will have to compile this particular class and come up with a bytecode version of the class. So after compiling this class, what I will get is a bytecode version, that is my class dot class file. Okay, which is a bytecode version of the class. So first I will create a folder, that is my project. Now within this folder I will create a subfolder or subdirectory with the name my package. That will be the exact name of the package that I am going to create. Then within this my package I will create a class, okay, say my class.java. After writing the class definition, I will compile this particular class my class.java into a bytecode version. Now once that is done, in the source code I will be writing the source code. In the source code I will be importing, okay, using import keyword I will be importing my package dot the class called as my class and semicolon. So by writing import my package dot my class, okay, I will be able to access the methods which are there within this particular class. Okay. Now before writing this particular program, one more thing I want to tell you, that the class which you are going to write over here, that is my class, you will have to declare this my class as a public class. Why? Because who is going to access the who is going to create object of this particular class? It is the source file or source.java that will be creating the objects of this class. That means source.java will be instantiating this particular class. So unless and until I don't declare this class as as public, okay, it will not be visible outside its own package. Similarly, suppose this my class.java has one method that the source.java is going to call. Okay, that method also we will have to declare it as public, so that it can be accessed from outside its own package. Okay, so with this particular understanding, let me write a simple program, and I create a folder called as test program. Now in this test program, so this is that folder test program. In this I create a new subdirectory, okay, and I name it as my package. So all my packages will be housed in this particular, all the classes within the package called as my package will be housed within this subdirectory. So my package is the package and all the classes will be written inside it. So let me go ahead and create a new class. Okay. So let me create a new class. Again, the class that I am going to create, this class, it has to be a public class, right? Now the class called as my class, which I am going to write over here. Okay. So you have to save it. You just say file save as my class dot java and save is as all files and just say save. So a Java file called as my class has been already created. Now let us write the code for this my class. First, this my class is present in which package? My package. So I just write package my package. Now the class name, that is my class, as I have told you, it has to be public class, otherwise it won't be accessed from outside this particular package. So I will say public class my class. And in this class, I have say one method, say display. So I'll say void display, and let's say this method only displays a message, say hello world. So I'll say system dot out dot println, and it prints hello world. Okay, again see, this method will be accessed from outside its own package, so it has to be public method. So I will have to write public void display. So this is a simple definition of my class. Okay, since it is this my class is housed within a subdirectory called as my package, you will have to write here package my package. So you save your program, and now you are going to create the byte code of this particular file, and copy this path, yes, and now you have to compile this my class. So I will say javac my class dot java. Okay, now after compiling, you can see here that my class dot class. So this is the bytecode file that is created. So what has happened is, in my test program project, I have a package that is being created called as my package, and within this my package I have created a class called as my class. Okay, we have already seen the definition of that my class, and there is a bytecode that we have generated. Now let me write the source program. So I create a new file, I save that file as source.java, src.java, okay, and now how will I write the code? First of all, what I will be doing here is, this is my source program in which I will be having public static void main function. It will be accessing my class from my package, and it will be calling the display function from that my class. Okay, so let's write the definition. So since I want to import, I will say import my package, import my package, and my package houses a class called as my class. I will say import my package dot my class. Now many a times in your package you might have multiple classes, so you will have multiple bytecode files, right? And many a times if you are not sure exactly which class are you going to use from a given package, if you are not sure, then you can simply say import my package dot star. So when you say dot star, it will import all the bytecode files which are there in the given package. But here you know which one, so I will retain the same my class, and now I will write the definition of the class. Class source, again it should be public class. Okay, and here I will write the definition of the source class. So you will have public static void main, okay, and in void main I am going to just create object of this class called as my class. So let me create object. I will say my class, my class C equal to new my class. Okay, now here you have to follow the naming conventions. It is my class, C capital. Okay. So I have created object of my class, and then using that object I'm going to access which function. So in this my class file you have a display function, public void display. So using the object of my class I'm going to call this display function, right? And then you save your program. Fine. So far what you have done in this project test program, you have created a package. Within package you have created a my class that houses a method called as display, which will print hello world. Then outside this package you have your source file, source.java, in which you are just creating object of that class from the package called as my class, and you are calling the display function from that class. Okay. Now once this is done, now let us execute this program and just see. Okay, I'll say java c src dot java. Okay, so again this program is compiled, the dot class file has been generated, and now I'm going to run this particular program. I'll say java src, and you see the hello world has been printed. Okay, so coming back to the concept of creating a simple package, what we have done is we have created a simple package called as my package. Creating a package means creating a subdirectory within the project folder. So you have created a package called as my package, then within the package you have created a class called as my class, right? And then after creating that class called as my class, you have converted that to bytecode, you have compiled that class. Then in the source program, that is source.java, you have imported that particular class. Okay, and then you are creating objects of that class in the source file and you are executing it. So this is how you can create packages, and you can access packages using the statements like import package1 dot package2 dot package3 and so on. Notice that many a times you may have a subfolder within another subfolder. Okay, as you can see in this example, okay, as you can see in this particular example, your package1 and your package2, okay, package1 and your package2, they are different folders. So package1 is one folder, package2 is another folder, and there is package3, that's a innermost folder, and within package3 there is a class called as class name. Okay, so if you want to import in your program, if you want to import this particular class called as class name, then you will have to write import package1 dot package2, which means within package1 there is package2 dot package3 dot class name. So this is how you can access the packages. Now using a package, okay, now we have just created a simple single package and we have seen how to use the package. Okay, now next we shall see how can we import classes from packages. Suppose in your project you have more than one package, okay, then how we can import different classes from this more than one packages in one source program and execute. Now for that, let us see an example. So I have a folder or directory called as source files, and my source program is present in this source file. Now within this source files, I have my package test1. So this is the source code file which will have public static void main. Okay, and I have created two packages. This is package1 and this is package2. Now let us see package1. In package1 there is a class called as class A. Let us see the definition of class A. So while declaring the class A, while defining the class A, I have to declare here package1, which says that this class called as class A is present in package1. Now again it should be public declaration, access specification should be public, because this class should be, you should be able to access this class outside this package. The source file should be able to access this particular class. So, public class class A, and this class A, it houses one method called as display A, which simply prints a message class A. Okay. So, this is a simple class. Okay. This class called as class A contains a method called as display A, which will simply print on the screen class A. After this, using command prompt, I have compiled this particular file called as class A, and this is the bytecode file that is generated. Okay. So, this is what is present in first package. In the second package, I have created another class called as class B. Okay. Now, this class B, again I am saying here that this particular class B is housed within the package called as package 2. So, I have to write here package 2, which means that this particular class is housed within the subdirectory or package called as package 2. Let us see the definition of class B. It has a protected int variable called as m with value 10, and then it has a method called as display B, which simply prints that class B string, and then it just prints the value of m, that is 10. So, also notice that this class called as class B as well as the method called as display, both have to be declared public. Why? Because they will be accessed from the source code which is there outside the package directory. Okay. So, it is only public visibility label that can make a particular data element be accessible outside its own package. Fine. So, this is the definition for class B. Again, I have compiled this class and I have got this bytecode version, that is class B. Okay. Now, after creating two packages, next I have my actual source code, that is package test 1. So, let us see. First, I have written an import statement. That means, this particular source code of mine, it imports from package 1 class A. Then I have written this source code also imports from package 2. Now, if suppose there are multiple classes present in a particular package called as package 2, and you are not sure which package, which class in that package you can use, you can just say dot star. Otherwise, you can just specify whichever class that you want to import from that particular package. So, just to show you, I have just written this import package 2 dot star. Okay. Now, this is your class called as package test. This is the source code which houses public static void main. As you know, when the program is executed, the interpreter is going to read the first line from this void main method. Okay. Now, in this void main, what I have done is I have created an object called as obj_a of class A from package 1, and then I create object obj_b of class B, which is there in package 2. So, obj_a is from the class which is defined in package 1, obj_b is the object from class B that is defined in package 2, and then later obj_a object calls the display A function of that class called as class A, which is housed in package 1, and obj_b then calls display B method, okay, from the class B that is housed in package called as package 2. If I had not defined display A and display B as public methods, okay, I was not able to access them here. Also, if I had not defined the class A and class B as public in the definition of those classes in the packages, I would not be able to create objects of these both these classes outside their packages. Okay. So, this is a simple code. Now, let us execute that code. I say javac package test 1 dot java. Okay. So, dot class file has been already created, and now the interpreter is going to interpret this particular bytecode called as package test 1. So, I will say java package test 1. So, as you can see, object A is the object of class A from package 1, object B is the object of class B from package 2. Object A will call its display A function, and display A function or method, the definition says that it simply prints a message on the computer screen, that is class A. Similarly, obj B, that is the object of class B from package 2, it calls display B method, and display B method does what? It simply prints class B, and then it prints that protected int variable m whose value is 10. So, this is a simple program that shows you how you can have multiple packages in a project file, and how the source code can access different classes from multiple packages. Next, let us see how can we do the subclassing. Okay. Now, here what we are going to do is, we are going to first import a class from a particular package. Okay. We are going to import a class from a particular package, and then we will try to make our class a subclass of that particular class from the package. So, let us see that code now. So, this is again my folder called as source class that I have created. This folder or this directory, it houses my source code program as well as the packages. So, I open this particular directory, and in which I have another subdirectory called as package 2. Now, package 2 contains a class called as class B. Let us see the code of that class B. First, I am writing here package 2. So, I am specifying that this class B is supposed to be a class from package called as package 2. So, which means the class B is a class from a subdirectory called as package 2, right. Then public class B. So, this is a definition of the class. Notice that I have to declare this as public, because if I do not declare this as public, okay, this class B, its objects you will not be able to create outside this particular package from the source program, from the main class. Okay. Now, here again I have a protected integer variable m equal to 10, and there is a simple display function, okay, which prints class B on the computer screen, and again it prints the value of m on the computer screen. Okay. So, this is basically the class B which is there in the package. Then using Java C compiler, I compile this class B, and I have created the bytecode version of it. Okay. So, that is this dot class file. So, this is the package data. Next, I have a class here. Okay. So, what I am doing here is, this is my package test 3. Package test 3 is supposed to be the source code file. Package test 3 is supposed to be the source code file. Now, what happens is, in this package code test 3, that is a source code, I am first saying that I am importing class B from package 2. So, I am importing this class B from package 2. Okay. So, the bytecode is getting imported. Now, in this source code of mine, okay, apart from public static void main, so package test 3 is the name of the file, Java file, but apart from this particular class, there is another class that I have created, and that is called as class C. Okay. Now, this class C inherits class B. Notice that class B is basically a class present in package 2. So, my class, that is class C from the source code file, class C from the source code file is inheriting class B from the package, that is package 2. Now, what class C does? Class C also has a variable called as n and a display function called as display C. I do not have to declare this class C as well as the display function as public, because it is within the source code file. Okay. So, this display function, it simply prints class C on the computer screen, then it will print the value of m. Now, this m is basically a value from class B. since class B is being inherited by class C, it is able to access M. So, this is how M will be printed, and N will be the value of this class C itself, which will be 20. So, it is trying to print this. So, this is basically class C. Now, in my main, I am creating object of this class C, of this class, okay, and the object name is objC. Now, using that object objC, I am calling display B function or method. Now, where is display B method? Display B method is a method of class B, okay, and where is this class B? Class B is basically in my package called as package 2, okay. So, since class B is being extended by class C object should be able to access the method called as display B of class B. So, object C, object of class C calls display B of class called as class B from package 2 and will execute the code, and then later on it calls display C method of its own, okay, and will execute this, okay. So, now let us compile and execute this source code. CD. Now, I compile this package test3. So, I will say Java C dot Java, and then I say Java. I run this code. So, you can see there class B and n equal to 10. This is basically the output that is generated by calling display B method of class B in package 2, whereas the remaining part, that is printing of class C, printing of m equal to 10 and n equal to 20 is done by display C function, which is part of package called as package test3, okay, here. So, this is how you can just import a class, okay. This is how you can just import a class, and that class can be inherited by whichever class that you are creating in your source code, okay. Next, let us see how can we add a class to the package. So, for that, again say this is a source code, this is a directory which contains my source code on n my packages. So, I go to that directory in which I have a source code file that is called as source class. Now, this is a package which I have, and in this packages, in this one package I have created two classes now, not one class. I have got two classes in the same package. A class is the first class. What this A class does? The definition says that this A class, it belongs to package called as A package. Again, you have to declare this class as public. The definition is it just has a public function called as display A, and it simply prints class A on the computer screen, okay. Then I have also created another class called as B class. Again, you are saying that B class is part of A package in the same package, and then it has a method called as display B. Again, see, both have to be public, class as well as the method, otherwise it won't be accessible outside the package, right. So, public void display B is the method, and it just has a message printed on the computer screen, that is class B, okay. So, simple two classes that I have created in the package. Then next I compile A class, and this is the bytecode file generated. Then I compile B class, and this is the bytecode file that is generated, okay. So, this is how two classes from the packages have been compiled into the bytecode. Now, let us see our source code file. So, in source code I am saying that I am importing class A, that is a first class from A package, and then I am saying I am importing class B also from A package. Instead of writing these two import statements, I could have written only one import statement saying that import A package dot star. So, if I write import A package dot star, all the classes which are there in the A package, okay, all of them will be imported. But I am just showing you with two import statements, right. Now, what this source code does, so this is a class for this is a class called as source code class. In the void main, it creates obj A, which is an object of A class, okay, and obj B, which is object of B class. So, as I have told you, this A package contains two classes. So, in the source code, one object is created of A class, second object is created of B class. Okay. So, this is how two objects are created. Then the object of A class calls its function called as display A, and object of B class, it calls its function called as display B. Okay. So, this is how in a class, in a package, you can have multiple classes, and in the source code, this is how multiple classes from the same package can be called and it can be used within your code. So, now let us quickly execute our source code, source class, and let us see Java C source class dot Java. So, bytecode file or dot class file has been created, and now interpreter is called, I will say Java source class. So, as you can see, class A is printed on the computer screen and class B is also printed on the computer screen. Okay, we will now see a small concept, that is how to hide the classes. Okay. Now, suppose I have a package, okay, I will call it as my package, and suppose in my package I have some classes, say I have a class A, then class B, class C till say class N. Then I have converted all these classes into the byte codes, and let us say byte code of all these classes are there. Okay. Now, many a times what happens is, although I have a package, I may want one or two different classes, okay, not to be accessed by any program from outside the package, right. So, now if I want any class to be instantiated outside this package, as I have told you, I declare it with public. So, I make it public, right. But what I want is, I want to hide this class C. I want to hide this class C. That means, I do not want anybody, any program from outside, I do not want it to import the package and access this class C. I do not want to do it. Then what you do is, you do not declare that particular class as public. So, by making a class within a package, by making it non-public, you can hide that class from the outside program. So, this is how you can hide classes from the outside programs, outside Java programs, okay, just by making the package class non-public. So, whichever classes within the package are public, they are freely accessible by all the programs from outside this package. If you want to hide a particular class within the package, you do not declare it as public, you make it non-public. Okay. And lastly, we are going to see a very important concept called as static import. In this code, as we have already seen, there are some Java API packages. There is one package called as java.lang, and java.lang houses a class called as math. We have already used this math class for using different mathematical operations. So, what I am saying here is, I am saying import java.lang.math.star. By saying this, what I mean is, I want to import everything, okay, I want to import everything which is present in math library. Next, I write a class called as mathop. I write a class called as mathop. Okay. Now, I can also write it like this. I can just say import java.lang.math. Okay, that means I want to import everything which is there in math class. Now, notice that in a package, okay, okay, you will have different classes, and in classes you will have different methods, okay, which are public methods, and there are something called as static fields. Okay. Now, suppose I am importing this particular package, okay, so that this class is accessed, then all its public methods can be accessed, and also there are something called as static fields. All the static fields in a class can be also accessed, right. So, here this math class, it has a static field called as pi. Okay. So, just see the code. I am writing a method called as circle. It takes a parameter of type double, and then it calculates the area. For calculating area, it uses in math class, in math class there is one static field called as pi, which refers to 22 by 7, okay, 3.14159, a big number. So, Java developers, they have availed you with math class, and within math class they have availed you with a static field called as pi. So, you can directly use it, okay, without declaring. So, now what I am doing is I am just writing here double area equal to math dot pi. Okay. Since pi is a static field, object did not call it, okay, it is not in the scope of a object. So, to access any static data member, as we have already seen, you require class name and dot operator. So, class is math dot pi, pi is a static field. So, by writing math dot pi, we are accessing a static member of the class called as math, okay, which is pi, and pi contains the value 3.14159, a big number which is a value of pi. So, that value into p into p. So, this is how we calculate area of circle. It is pi r square. So, this is pi, and the radius value is passed from the main through this double variable p. So, it is area is nothing but pi into p, that is radius square. And then finally, I print a message that area of circle is area. So, whatever is the answer, it is getting printed. Now, in the public static void main, I just create object m of type math op of this class, and then m is going to access method called as circle, and we are going to pass value 2.5. Okay. So, by writing this much, okay, let us execute this code, and I go to that particular folder, and then I execute my code, that is Java C math op dot Java, which creates a object file, which creates a bytecode file, I am sorry, dot class file, and then I use the interpreter, Java interpreter, to execute this math op. So, it prints that the area of circle is 19.634954084936208, a big accurate value. Okay. So, this is how basically we can use the Java APIs, okay, directly, API packages directly. Now, what I want to show you now today is something called as static import. Now, from Java version 5 onwards, what they have done is they have used a concept, they have added a feature called as static import, which means that, see, now pi is basically a static variable, or pi is a static field in the math class. Every time that pi has to be used in the program, I have to associate pi with the class to which it belongs, because pi is a class variable or static variable. From Java version 5 onwards, they have allowed us to use something called as static import. Now, as we have seen in the previous example, this pi is a static variable of the math class. So every time that pi is used, we have to write math.py. What if I just want to not associate the class name with pi? Okay, so in that case we use something called as static import. So while writing the import statement here, I will have to write import and I will have to just add a keyword called as static. I say import static java.lang.math.star. Notice that math is a class. Now within this math class, you may have many static many static fields. One of them is pi, but you may have many. So by writing keyword called as static here, I am telling that import all the static fields which are present in math. Okay. By writing star over here, I am just saying that I want to import all the static fields which are there in the math class. Okay. So now you see in this particular code, I am no longer writing math.py, I can directly say pi, which is more readable. Now let us see by doing this change, by introducing a keyword called as static here, by writing here math.star and by just writing here pi, by doing only this changes, let us see whether the code can again run. And say Java C, okay, and I will say static math op dot java, and then I execute, I call the Java interpreter and say static math op. So it again gives me the correct answer like how it was given in the previous example. So this is an example of something called as static import, wherein all the static fields which are there in a class such as math class, all of them can be at once imported by using a keyword called as static, so that whenever you are using that static member or static field in your code, every time you do not have to write it like with class name dot your static member name. You can directly use the member name like pi. You do not have to write here math.py, you can directly use it as pi. So this is a facility called as static import. This is enabled from Java 5 version onwards.